Hello to one and all. So, in an effort to continue to put more physics videos up, today we are going to introduce graphs. So, graphing of kinematic functions. Kinematic just means moving stuff. Kinetics, motion. And so I want to introduce how to graph these ideas. So we'll kind of work our way up over the next video or two. We'll see how the timing goes. But without further ado, off we go. So before we get started in a discussion of kinematics, we have to start at the very basics. In some of the introductory videos for the physics section, I talked about how the first thing that you always need to do is to define your axes, which way's up, which way's down, which way's positive, which way's negative. And in general, it should be fairly self-explanatory. If an object is moving to the right or to the up, those are generally your positive numbers. If an object is moving to the left or to the down, those are usually negative numbers, and the permutations thereof. So what I usually do is in the corner of anything that I'm working on, I usually draw something that looks about like that. So that tells my reader that up and to the right are positive, therefore the opposites to the left and down must be negative. So, first thing, starting with kinematics. Since kinematics is motion, and whenever something is moving, it is going some kind of distance over some kind of time. Think about the little car moving down the highway. It takes him X amount of time to go X distance. Distance, when we say the word distance, we are talking about total steps taken, total miles driven. This is a cumulative function, and direction is not taken into account. So, if somebody were to walk 10 meters to the right and then turn around and go 10 meters to the left, it does not matter. They have still walked a grand total of 20 meters. So, whenever we graph that, since time is forever marching onwards, we put that on the x-axis, and the distance is our independent variable. That's the thing that's changing, or that we are changing ourselves. That goes on the y-axis. In general, distance is in meters and time is in seconds. I hope you can see that pink. If it's too hard to see, let me know, please, and I will redo this. If our person started at whatever their starting point is and time began to march forward, let's say they walked 10 meters and then they turned around and walked 10 meters the other direction. It does not matter. Their amount of distance they have covered is still increasing. Let's say they walked 10 meters and then they stopped for whatever reason. If they stop, distance is no longer increasing, however, time continues to march forever forward. So that would be represented by this flat line here. So we have moving is my line with a slope, and then stopped. Time marches forever forward, however, our distance, our y value, is no longer changing. Similar to distance is his close cousin, displacement. Displacement is distance with a direction. So now all of a sudden I care which way I'm going. I care very much. Think of this as how far are you away from your starting point. So back to our person that walked 10 meters and then turned around and walked 10 meters back. My distance increased as I walked away, but then I turned around and headed back. So my displacement decreased because I'm heading back towards my starting point. According to this graph here, my total displacement is 0 because my person, my car, my thing is back at their starting point. So again, displacement, how far are you from whence you began? Distance is just how far did you go. I don't care what direction, just how far did you go? How many miles did you travel? How many steps did you take? Since we are including both distance traveled and direction taken, now all of a sudden we introduce the idea possibly of negative displacement. Let's say that person walked 10 meters, turned around, came back to their starting point, and then kept going. If you think about this, numbers are increasing up the number line as we are increasing our distance from our starting point, and then I turned around and I came back. So at this point, I am back where I started, back at the beginning. However, I continued onwards past my starting point. And if you think about these numbers, although they are negative, they are increasing in that negative direction because I am still moving. I am covering new distance away from my starting point in the negative direction. So use those negative signs to indicate which way you are going. Now that we've talked about moving a particular displacement over a particular time, it only matches suit that we should begin talking about speed and velocity. So when we are going a particular distance in a particular amount of time, we are talking about speed. So speed is just how fast are you going. This is what the speedometer reads on your car. How many miles are you traveling over a given amount of time? So once again, speed does not include a direction. Since we are using distance, not displacement, this is cumulative. How far did you go? How long did it take? If you are cruising along the highway, you are going at a constant speed. It is not changing. Just like our displacement or our distance graph up here, this stop was a flat line because my distance is no longer changing, but time marches forever forward. The same thing can happen here with our speed graph. So if this was 5, for example, 5 miles per hour, and we went 5 miles per hour for 5 seconds, that would be indicated by a straight line right there at 5, because it is not changing. Let's say from there you need to accelerate onto an on-ramp. That's a new word. Acceleration is a change in that speed. If I am going faster, that means my speed is increasing over that period of time. So again, a sloped line means a change in my y function. Up here, sloped line, this was a change in my distance. Down here, speed, this is a change in my speed. Velocity, just like displacement, is the close cousin of distance, but displacement is distance with a direction. The same thing holds true with velocity. Velocity is speed with a direction. So in this case, velocity is in fact a vector. It has a magnitude and a direction. And we use displacement. I'll give it the vector hat just so you know it's displacement over time. A lot of